The Historian at Work. The challenge of evaluating evidence from the past, the challenge for every historian. And in this course, we'll be laying a lot of emphasis on your powers to assess and weigh up evidence from the past. In doing this, there are certain things to be aware of and to be wary of.
One of the things which strikes the outsider most when he looks at history is the plurality of divergent accounts of the same subject which he finds. At any given point of time and place, there are available differing and apparently inconsistent versions of the same set of events, each of them claiming to give, if not the whole truth about it, at any rate as much of the truth as can now be come by.
This side of the cassette is in two parts, each concerned with how historians work. Both look at the problems involved in doing history and are case studies from the history of mathematics. Some of the issues raised will recur throughout the course. The second part of this cassette, which you should only listen to towards the end of your study of the Greeks, looks at the evaluation of evidence from ancient Greek mathematics. Part 1 deals with a subject you will now be familiar with, megalithic maths, and the controversy surrounding Alexander Thom's theories.
I get a tremendous thrill when I come over the top of a hill and see a circle lying amongst the heather. The problems they solved without pen and pencil and without logarithmic tables and so on were remarkable. These people were researching into geometry, but all the time they were controlled by this convention that they had to have it whole numbers. They wanted the thing to have perhaps this hidden significance. The experts, the priests or what you call them, they knew what was in it. This hidden information which was stored away in this construction.
Professor Alexander Thom recorded on the hills some years ago for a television programme about the megalithic sites that he was so enthusiastic about. History isn't just about facts, but about evaluating evidence. This is really one of the most controversial discussions you'll come across in the history of mathematics. Not all arguments in history are as polarised as this one, but let's take it as an example, as it highlights some of the difficulties. The British Society for the History of Mathematics spent some time at one of its meetings discussing Alexander Thom's theories. There were two main speakers, Dr. Archibald Thom, Alexander's son, who shared in his father's work, and Dr. Clive Ruggles, who has resurveyed many of Thom's sites and has written extensively about megalithic man.
The motivation for these two talks, and indeed for an awful lot of work in this subject during the last few years, has been the fieldwork of Professor Thom. There are three distinct hypotheses concerning the megalithic sites that Professor Thom brought forward. One of them is the idea that some of the sites were astronomically aligned for whatever reason. The two other hypotheses, which I see as effectively independent, are the idea there was some unit of measurement used in laying out some of the sites, and lastly the idea that there were some sort of geometrical designs. Archie's talk, which follows, he's actually going to talk about the geometry. We will give you two rather different points of view on things.
By the way, I have really got about 40 minutes to talk about what is in about 5 books. A circle's dead easy to make. Anybody can make a circle. And you march up to a site and you look down the middle and you're standing about here and you think, well, this looks like a beautiful circle. And then you put a tape onto it and you find that it's not got the same radius all over. So what were they doing? They were doing something with units.
Any subject is dynamic. You have views that change all the time. You want to exchange. It's not as if something is there in a textbook written. It's a subject people have ideas about, and we're wanting to update and exchange them.
Conferences like this are useful because you are meeting face-to-face rather than corresponding with them by letter.
No subject is really static. We're all having new ideas. We're going out and doing new things, and we want to exchange them with everyone else. The conference has featured 3 papers on megalithic mathematics, myself and Dr. Thom. It's a tribute to Professor Thom, Dr. Thom's father, who died in November of 1985, and really a tribute to the vast amount of work he's done and the research that he's generated.
After the conference, we spoke to Dr. Clive Ruggles and Dr. Archibald Thom and asked them about some of the difficulties over evidence.
Let's think of a case in the geometry of megalithic rings where you can distinguish between fact and theory. A fact is that a megalithic ring is an egg shape. Now, an egg is a particular geometrical construction. Hypothesis, that ring actually was set out using that particular construction. Now, there's a definite distinction there because even though the geometry of the ring may fit that particular shape, that may not have been the way it was actually laid out. It may have arrived that way because it was simply a bad attempt at a circle. The facts are simply what you've got there in your archaeological or written historical record. And the hypotheses, and the interesting thing is what motivated people and what the social structure was like.
Facts and hypotheses. For this first case study, we have no written evidence from the time, but our evidence is all archaeological, which has its own particular problems.
We come to this question of whether you should, how much interpretation you should add on to the hypothesis, add on to the facts. We're hitting here, I think, against the two different approaches. On the one hand, I suppose the person trained in numerate sciences, whose evidence is going to be of a more statistical nature, who wants to see patterns repeated before they believe those patterns are really there, as against the approach of the archaeologist, say, who knows that, well, I mean, we're not dealing with the physical universe here, we're dealing with human beings, and human beings don't do the same things over and over again. In order to take account of that human diversity, you need to be interpretative. You really need to be very interpretative.
Well, we've already looked at some interpretations of the megalithic rings and Alexander Thom's views in 1C in the source book, Megalithic Evidence and Comment.
Let's try and summarise the 5 different views that we've got here in the book. The first one, Alexander Thom's, is explaining the evidence he's got, the geometrical evidence. He's got the Pythagorean triangles. He's done his statistics. He's got a precise megalithic yard. From that he interprets there has to be a megalithic yardstick. He then assumes that there are people who must have been taking up and down this megalithic yardstick. And the way he's arrived at that is by the evidence as he sees it. He's not gone to libraries. He's not worried about what archaeologists have thought. He's thought through that process, and that's the conclusions that he's arrived at, both on the basis of his evidence. The Stuart Pigott reaction to that is quite interesting. It's the opposite end of the spectrum.
However cogent Thom's reasoning may be on purely mathematical grounds, many archaeologists would feel that a great number of difficulties have not yet been faced in an evaluation of this hypothesis. There's always the danger of seeing ourselves in the past, of becoming victims of the fallacy whereby ideas are imported from present-day experience and ancient man is anachronistically saddled with views that he would have found at best strangely unfamiliar.
He comes along and he says, OK, I'm an archaeologist, I have some ideas about prehistoric people who built these standing stones. All this stuff doesn't fit in with my ideas. How could they have had a yardstick? It must be wrong. And it doesn't really imply any reassessment of the evidence provided by the Thoms. So really, these two views are bypassing each other. They're looking at different evidence and they're arriving at different conclusions. Now, Ewan Mackay is a sort of link man in here. Here's an archaeologist who comes along. He embraces the Thoms' views. He has a look at their evidence, decides that he believes their conclusions, links that in with other archaeological evidence, and derives the fact that he thinks there were astronomer priests who actually had great astronomical knowledge and geometrical knowledge, and this was how this was passed on. And so Ewan Mackay has actually put these two views together and tried to merge them in a way.
One aspect of the detailed conclusions made by Thom about the megalithic yard, fathom and rod in the stone circles cannot pass without comment. This is his deduction that the evidence plainly shows that the megalithic yard was carried in the form of actual rods of standard length, made from wood or bone from one end of England to the opposite end of Scotland. Ireland has not yet been investigated. And without varying in length more than 3/100ths of an inch. In other words, the metrology and geometry that the circle builders used in their projects was highly organised to the extent that the lengths of the measuring rods were standardised at a single centre. If it's correct, this deduction must have very important implications for the social organisation of late Neolithic and early Bronze Age Britain, since it's scarcely conceivable that such a situation could have come about unless there was one major training centre for the wise men of that period, where the appropriate knowledge and skills were taught by the wisest of the order, and from which the graduate astronomer priests and magicians were sent out all over the country.
Now, the last two people come along and put interpretations of different kind on top of the Thom views, I think. We have Van der Waarden, who now takes the Thom views, I don't think as critically as Ewan Mackay did, who's just sort of taken the conclusions, lock, stock and barrel, and sort of merged them in with various other things of European archaeology, and derives this wonderful picture where, instead of the classical idea of diffusionism from the Middle East, the idea that every achievement that was ever made in prehistoric Britain came in from the Middle East, he sort of has an anti-diffusion idea in which it went the other way.
I have ventured a tentative reconstruction of a mathematical science which must have existed in the Neolithic age, say between 3000 and 2500 BC, and spread from Central Europe to Great Britain, to the Near East, to India, and to China. Can we make a reasonable conjecture about the place of origin of this mathematical doctrine? The Beaker people, who built Stonehenge II, Woodhenge, and other henges, came to England from the continent shortly after 2500 BC.
In a sense, I feel that's just heaping interpretation on something that was a bit interpretative in the first place. Knorr, on the other hand, leaps in, again, doing the opposite. He comes in criticising, on reasonable grounds, he criticises the megalithic yard and the megalithic geometry on the grounds that it's intrinsically implausible. What he means by that are some fairly specific things. He has some ideas about the culture. In a sense, this is fairly similar to Stuart Piggott, I guess.
It seems to me that the sensational impact of finding such complex geometric patterns in these ruins has obscured, for analysts like Van der Waarden and the Thoms, the phenomenal difficulties implicit in their views. A comparable insensitivity to deeper implications bears on the Thoms' hypothesis of the megalithic yard, the common measuring unit inferred from measurements of the diameters and circumferences of hundreds of Neolithic rings. Surely, the notion that the Neolithic builders adopted such a standard unit must be considered intrinsically implausible. How could such a unit be kept standard over more than a millennium and a geographical area of thousands of square miles? What would the standard be made of? Wood? Stone? And where would it be kept? How could a population of dispersed, migratory, agricultural tribes maintain standardized measures? Or even want to?
I think those sort of questions are important. They should be taken into account. But again, he's not gone into any of the detailed evidence, the statistical evidence. Really, in a sense, the different types of evidence that come in here, that sort of archaeological thinking of Knorr's, which is important, together with the statistical thinking that Professor Thom has done and others do, really you need to interpret the two together to form a proper opinion.
Many people studying prehistory start out with the idea that the people 4,000 or 5,000 years ago were not intelligent. They couldn't do this, they couldn't do that, and they couldn't do the next thing. In fact, they were probably better human beings than we are, to the tune that they existed under most difficult living conditions. I would like to put out the point of view that they were deep thinkers. How, for instance, did the agriculturalist know how to breed wheat, to select from the wild how to actually breed it and make better wheat? Now that is technology. We're discussing here, I know, mathematics, but there's not all that difference when it comes to that.
Yes, I can follow on from that. And the one thing you can say is that these people certainly had the capability to do all these things that have been suggested. I think the critical question is whether they were motivated actually to do that, whether they needed to, and whether they wanted to. And by trying to see these things in the past, we have to be so careful not to do what Stuart Piggott is saying, not to project our own aims and goals onto those people. Yes, they were capable of achieving them, but did they? Were they motivated to? There's a very great danger that if you know fairly little about the social conditions, the social structure of the people you're looking at, that you will impose your own ideas upon an alien culture. Any alien culture you look at, be it far away in prehistory or be it another culture in the world somewhere, you know relatively little about, and you have to make allowances for that. The most you can do is to look at other societies around the world. Perhaps an anthropologist is best equipped to do this. And so at least that gives you an idea of the diversity. You don't just think that people must follow the same intellectual paths as Western civilization, and that perhaps prevents you from imposing your own culture upon theirs. At least to some extent. You can never avoid doing that altogether, I think. There are a lot of archaeologists who would say that we cannot get at what prehistoric people believed. But there are a lot of others, especially in the new archaeology school, who think that you can get at that. But I think everyone is generally agreed that there has to be a lot of interpretation goes into that. You have a lot of subjectivity. I don't think anyone would deny that. If you're looking at people's belief systems, and when we're talking about things like geometrical layout of sites or astronomy, I tend to think that we are looking at that. And that's very different from pure technological achievement, which is much less subjective.
So our attention has been drawn to the need to evaluate evidence on several levels.
History very definitely isn't just about facts. In getting at anything that was going on, there is interpretation. First of all, you have very definitely to try to distinguish between the two, but even having said that you should be trying to do that, it's difficult. But that doesn't mean that it's all right to believe anything, because I think you have to have justification for what you believe, and I think that justification has to not just do for you, it has to be communicable to other people. You have to justify what you believe. You have to justify how you interpret the evidence. You have data and you have theories and you try and test them, but everyone wants to interpret at the end of the day. But you still have to justify that interpretation.
The theme of the historian at work is continued in the next part of the cassette, but you should switch off now and come back to this discussion after you had studied most of the Greek units. We now come to a second discussion on the historian at work. Before listening to this, you should have studied most of the Greek units. In his rooms at King's College, I spoke to Dr. Geoffrey Lloyd, Professor of Ancient Philosophy and Science at Cambridge University. Let's take the Greeks as an example and look at the sources of evidence we have for Greek mathematics.
Well, it's almost entirely literary. It comes down to us in the form of manuscripts, which in many cases date from the 12th or the 13th, sometimes only from the 14th or the 15th century, which we can supplement with a small number of papyri dug up from the sands of Egypt, which are very much older. Now, the problem of interpretation of this material is that the texts that have been transmitted to us have been selected for transmission by people working in mathematics, or maybe not in mathematics at all. If a text becomes a school textbook, it has every chance of surviving. And for some mathematicians, we're very much better off than we are for others. In the case of Euclid, which was one of the most remarkable textbooks of all time, we've got his Elements. We've got many different manuscripts of the Elements. But in the case of other mathematicians, such as Archimedes, we only have a single manuscript of one of his most important treatises, which was called The Method, and that manuscript was only rediscovered in Constantinople, I think, in 1905. And in many cases, we've got no evidence in the form of whole treatises from important mathematicians. For example, Eudoxus. Pre-Euclidean mathematics is very difficult to reconstruct, largely because of the success of Euclid himself. Because once Euclid was available, people didn't think it made sense to continue to copy out the texts, even if there were texts available in their time, of earlier mathematicians. But it's mostly literary. It's quite difficult to interpret because, in many cases, the manuscripts are not accurate, but mathematics is different from literary texts of poetry, or it might be philosophy. It has one advantage over them in that, in the case of a mathematical text, we can often amend the text quite securely on the basis of what the mathematics tells us must be the case, what Euclid must have meant in a particular context. On the other hand, there's also a disadvantage with mathematics related to that point about school textbooks, because there's a temptation in the process of transmission for the text to be improved by people who want to bring it up to date, who want to make it a better school textbook. And, of course, that means that we don't have access to the original words as written down sometime in Alexandria about 300 BC in that case, and in other cases a similar argument applies.
What sort of problems do you have with evidence, just in summary? What are the main pointers to watch out for when looking at evidence?
The bias of the sources, the interpretation that the sources have put on the material that they give us, that is the overwhelming difficulty.
Do historians disagree about ancient Greek mathematics?
A lot, yes, of course. But there are disagreements and disagreements. So one can begin with a disagreement about what one should put at a particular place in a particular theorem of Euclid, where it's a matter of evaluation of the manuscript tradition and of such other evidence as we have, and there will be a little argument between specialists on that subject. But of course, much more important and much more common, there's a question of dispute. There are disputes about the nature of Greek mathematics, its presuppositions and its aims, and the way in which Greek mathematics joins on to Greek culture and Greek society generally.
One of the main controversies is between the influence of philosophers and mathematicians.
Absolutely. There's an important dispute between a position that has been advocated, for example, by Szabo, which has it that deductive argument and demonstration was first developed in philosophy, and that the mathematicians are really in debt to the philosophers, directly influenced by the philosophers in the main, and that it's philosophy that takes the credit for this development. We shouldn't think of the development of deductive argument in mathematics as being independent of philosophy. The contrary point of view has been argued forcefully, for example, by Wilbur Knorr, and that has it that although it's true that the first texts that we have of deductive argument in philosophy antedate the first good texts we have in mathematics, that shouldn't mislead us, that mathematics develops largely independently of philosophy, and that the very evidence that is cited for the first deductive arguments in mathematics is also evidence for the independence of mathematics from philosophical influence. Now, to get the record straight is very difficult, but one thing we can and should guard against is anachronistic ideas about what it was to be a philosopher, what it was to be a mathematician at that time.
You're putting sometimes an interpretation from our present standpoint onto the past.
Yes, I think that on both sides of that particular dispute I've referred to, that is happening. The position I would want to take on this issue is that we've got to look very carefully in the first instance at what philosophy meant, and many of the philosophers are also interested in mathematics and vice versa. And that's not just a trivial point, it's absolutely essential, I believe, to understanding the intellectual developments in the 5th century BC in Greece, to understand that there are no hermetically sealed compartments corresponding to professions in the modern sense.
So the pitfalls that you're looking for in an argument where you've got a big controversy about the past, again to underline the points.
Anachronism. It's applying anachronistic categories to the understanding of ancient intellectual developments and cultural developments more generally.
And to what extent are historians, as the generations go by, building up interpretations on top of existing evidence?
Of course, that happens a good deal. That's to say, you get orthodoxies and you get traditions developing. But recently, in the history of ancient mathematics, there's been an opening up of debate. That debate that I've just mentioned would be one example of that. And I think that's healthy. Nobody could say there's an orthodox view about the development of deductive argument. There's no orthodoxy about such a matter as who Archimedes is drawing on for his work, whether he's influenced directly by pre-Euclidean models, is another case where there's a lot of room for disagreement that unfortunately is not going to be resolved. It may not be resolved ever, but it's certainly not going to be resolved very easily. Thinking about these disagreements between scholars helps one to see how complex the history of mathematics was, even in ancient times.
Why does Greek mathematics interest you so much?
Well, it's one aspect of the ancient world that I continue to find fascinating. It's not especially Greek mathematics, as opposed to Greek science or Greek philosophy or Greek medicine that I'm interested in, but the interaction between all of those does continue to fascinate me, because what's happening in the ancient world is really rather exceptional from many points of view. In the ancient Greek world, particularly in the 5th and 4th centuries BC, you have a situation where the society is changing, and the society is very open. I have to qualify that, of course, because in practice it wasn't as open as some of their own representations of it might suggest. Nevertheless, there's a good deal of evidence that in many aspects of Greek life there's an openness to new ideas and a possibility of questioning old ideas. Now, the question that all of this material poses is really under what conditions, what circumstances, and to what extent can any society become self-critical? How can it afford to challenge its own underlying assumptions? Now, that's some way away from the particular concerns of Greek mathematics, but Greek mathematics, in its innovativeness, was certainly an example of intellectuals, well, not necessarily all that intellectual, going ahead and developing certain inquiries and thinking about the nature of those inquiries in very radical and far-reaching ways, in a way that is characteristic of ancient society. And the particular question of what it was like to be an inquirer in mathematics or in any of the other disciplines I mentioned in the 5th century is one that potentially has relevance to us today, because we're still faced with the question of how the underlying assumptions made in our culture, our society, about different aspects of our life might influence us. How can we become self-conscious about those underlying assumptions, the invisible assumptions? And in Greek society, to a certain extent, they did become visible, and how they became visible and why they became visible does seem to me pose interesting questions.
So we've taken the Greeks as an example, looking at the question, what is history? But we're at the start of a course now, which is looking at the history of mathematics. What lessons can we learn from the way you've approached that, for the way we look at what is history throughout the course?
Well, I've emphasized some of the difficulties and some of the continuing controversies. It's a difficult subject, and there are going to be no simple solutions. But I would prefer to see that as an advantage rather than a disadvantage, because it encourages people. If I can address the people taking the course, it should encourage you to produce your own line of interpretation on the basis of your reading of the material that's been put to you, so that history can be an exciting subject. It's a very different subject from mathematics itself, of course, because in mathematics you're attempting to get results of a kind that is quite different from the results that you can expect from a historical inquiry. But history can be exciting and stimulating, and I hope you enjoy it.